Assalamualaikum warahmatullahi wabarakatuh. I'm Arif Iskandar and we're presenting to you Fluid Mechanics 1, Lab 1. So, our topic for lab is the hydrostatic force on a submerged body. Hydrostatic forces are the resultant forces that are caused by the pressure loading of a liquid acting on submerged surfaces. Calculation of the hydrostatic force and the location of the center of pressure are fundamental subjects in fluid mechanics. The center of pressure is a point on the immersed surface at which the result hydrostatic pressure force acts. The objectives of this lab is to understand the hydrostatic pressure distribution and to verify the location of center of pressure. The method of the experiment is that the hydrostatic force and center of pressure acting on a vertical surface will be determined by increasing the water depth in the apparatus water tank and by reaching an equilibrium condition between the moments acting on the balance arm of the test apparatus. The forces which create these moments are the weight applied to the balance arm and the hydrostatic force on the vertical surface. The procedure for the experiment is that the width and the depth of the reticular face were measured at first. The length from the pivot to the loop hanger was also measured. The 3 foot screws were adjusted until the apparatus is balanced, and this will indicate by the spirit level situated at the left base of the apparatus. The balance arm was adjusted until its level using the rider. The tank was filled with water using a measuring cylinder to the zero scale datum. The tank was filled with water again to a certain level about 1 cm from the top of the tank. The weights were placed onto the loop hanger to restore the balance arm to the horizontal position. The weights W on the loop hanger were recorded and Y2 was measured. It was repeated until values of weight were recorded. So this is the experimental setup of the lab experiment. You can see the level indicator, the balance arm, and the weight hanger and the spirit level to measure the horizontal. This is a result and discussion on the effect of partially submerged surface. So this is the theoretical height. We'll just measure height of the water when applied mass for partially submerged surface. This is the hydrostatic force acting on the vertical rectangular surface versus the measured height of water for the submerged surface. This is the center of pressure of the vertical rectangular versus the measured height of water per partially surface. While this is the effect on a fully submerged surface, theoretical height versus measured height of water when applied mass for fully submerged surface. This is the hydrostatic force acting on a vertical rectangular surface versus the measured height of water for the submerged surface. And this is the center of pressure of the vertical rectangular surface versus the measured height of the water for the fully submerged surface. In conclusion, hydrostatic force acting on a vertical rectangular surface act at both partially submerged and fully submerged increases as the height of the water in the chamber increases. The increase in mass also increases the theoretical height of the water.